Math 7, Unit 10, Target 10-5. 10-5, I can solve a one-step inequality using multiplication and division and graph the solution. In these examples, there are going to be no negative coefficients. A negative coefficient would mean that you would have like a negative 3x. The value in front of your variable would be negative. If the value in front of your variable is negative, it affects the inequality. We will talk about that later. Today, we're going to have positive coefficients. Review. In this review, there's a negative coefficient. When you were solving a one-step multiplication equation, you would divide both sides by negative 3. Negative 3 divided by negative 3 would be a positive 1. That's your goal. X is 1. 15 divided by negative 3 would be negative 5. So your solution, x equals negative 5. In order to prove that was true, you checked. Negative 3x equals 15. Substitute negative 3 times negative 5 equals 15. Negative 3 times negative 5, a negative times a negative is a positive. 15 is equal to 15. It checks. Our solution was correct. Now let's look at inequalities. 2x is less than 10. We're going to solve the same way that we did with equations. We're going to divide both sides by 2. X, 10 divided by 2, is going to give us 5. X is less than 5. Our solution is going to be x is less than 5. If we were to graph that, our boundary point is 5. It's going to be an open circle because it's less than. Since x is smaller, put some values in here. We're going to graph everything smaller or less than 5. Check. Let's rewrite. 2x is less than 10. Substitute in a value that's been graphed. Let's substitute in 4. That is less than 5. 2 times 4 is less than 10. 2 times 4 is 8. 8 is less than 10. It checks. So our solution is correct. Example 2. 3x is greater than or equal to negative 21. Again, we're going to solve just like a one-step equation. We're going to divide both sides by 3. X is greater than or equal to negative 7. Our solution, x is greater than or equal to negative 7. Negative 7 is our boundary point. Then we have a greater than or equal to, so we are going to fill in our circle. X is larger, so we're going to talk about everything larger. Let's put some values in here. Negative 7, negative 6, negative 5, negative 3, 9, 11. In order to check, we need to rewrite 3x is greater than or equal to negative 21. We're going to pick a solution that's been graphed, so anything larger than negative 7. Let's choose negative 5. 3 times negative 5 is going to be greater than or equal to negative 21. 3 times negative 5 is going to be negative 15, is greater than or equal to negative 21. That is a true statement, so it checks. We got it right. X over 4 is less than or equal to 8. Remember, x over 4 means x divided by 4. The inverse or opposite of division is to multiply. So we're going to multiply by 4 over 1. 4 divided by 4 is 1. That was our goal. We have x. If we multiply by 4 on one side, we need to multiply by 4 on the other side. We are going to end up with x is less than or equal to 32. Our solution is going to be x is less than or equal to 32. 32 is our boundary point, so that's what we're going to graph, 32. It is less than or equal to. Because it is equal to, we are going to fill in our circle. Let's put in some other values, 32, 34, 35, 36, 31, 30. X is less than, so we're talking about all of the values smaller than 32. In order to check, we're going to rewrite. X over 4 is less than or equal to 8. Pick a solution. Let's pick 30. 30 has been graphed. 30 over 4 is less than or equal to 8. 30 over 4 means divided by. 30 divided by 4 is going to be 7.5. 7.5 is less than or equal to 8, so our solution checks. Negative 24 is greater than 6x. Again, we're going to divide both sides by 6. Negative 24 divided by 6 is going to leave us with negative 4 is greater than x. So our solution is going to be negative 4 is greater than x. Negative 4 is our boundary point. We're going to have an open circle. X is less than, so we're going to talk about everything smaller than negative 4. We're going to check. Negative 24 is greater than 6x. Let's pick negative 6, that's been graphed. Negative 24 is greater than 6 times negative 6. 6 times negative 6 is going to be negative 36. Negative 24 is greater than negative 36. It checks, so our solution is correct. Pause the video, try these, then check your solutions to make sure you are correct. In this first one, x divided by 5, the inverse or opposite of dividing by 5 is multiplying by 5. We're going to do negative 6 times 5, which is going to be negative 30, is less than x. Our solution is going to be negative 30 is less than x. Negative 30 is our boundary point. We're talking about things larger. X is going to be greater than negative 30. Put some other values in here quickly. And then we can check. Rewrite negative 6 is less than x over 5. Let's pick a solution that's been graphed. Pick negative 28. Negative 6 is less than negative 28 over 5. Negative 28 divided by 5 is going to be negative 5.6. Negative 6 is less than negative 5.6. That is a true statement, so our solution checks. The second problem, we're going to divide both sides by 7. X is greater than or equal to 7 is going to be our solution. 7 is our boundary point. It's going to be a closed circle. And we are going to talk about everything larger. Check. 7x is greater than or equal to 49. We can pick 9. That has been graphed. 7 times 9 is greater than or equal to 49. 7 times 9 is 63, which is greater than or equal to 49. Our solution checks. For the check, as long as it's a value that's been graphed, the check will work. Today we talked about how to solve a multiplication or division one-step inequality and graph the solution.